Hey everyone, and welcome back. So before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also really helps us reach others in need of assistance with these topics. So what we're going to be going over today is trigonometry, and we're going to be actually calculating what the angle is in a right triangle using cosine, sine, and tangent trig functions. And we're going to be using the inverse of those trig functions in order to actually find what this angle needs to be shown on the screen here. So, and knowing that we are going to have to use sine, cosine, and tangent trig functions, we can use the acronym of SOH-CAH-TOA. And it will tell us what we need for each function. So the first one is so that'll be sine of our angle is equal to the opposite over the hypotenuse. The cosine, which is the COA, is cosine of the angle, is equal to the adjacent over the hypotenuse. And then finally, our tangent, which is the last portion here, is the opposite over the adjacent. So for the right triangle, we need to know all three sides in order to determine the opposite, the hypotenuse, and the adjacent values here. So we do not have the hypotenuse for the triangle. So looking at this angle here in the upright corner, the 3 would be the adjacent side, and the 9 would be the opposite side for the angle. So the adjacent side is always the side of the triangle, the leg of the triangle that is touching the angle. And the opposite side is always the other leg of the triangle not touching the angle. So the angle is touching this leg and the hypotenuse, which the hypotenuse is the longest of the three sides, or the slanted side, opposite the 90-degree angle. And the 9, which is the opposite side not touching that angle at all. So looking at what we have here, we have the adjacent, we have the opposite side. So in order to get this hypotenuse side, we need to use the Pythagorean theorem, which is written like this for right triangles, where we have our hypotenuse side squared plus the adjacent side squared plus the opposite side squared. So our hypotenuse side is just going to be the square root of our adjacent squared plus our opposite side squared. So let's go ahead and fill this in. So we would have 3 squared plus 9 squared square rooted, and that gives us a total of 9.49 after you do that calculation. So 9, oh, hang on just one second. That was ugly. So 9.49. So now we have all three sides determined. We have adjacent marked as 3, opposite marked as 9, and hypotenuse marked as 9.49. So typically, if you wanted to find the angle, you would just use one of the 3 trig functions. But this particular problem, we're going to use all 3 to solve for this angle here. Now, due to rounding purposes, the angle may not be exactly the same, but it should be extremely close using all 3 trig functions. So let's go ahead and let's set up the first one here. So let's go with sine of our angle is equal to the opposite over the hypotenuse, which our opposite is 9, and our hypotenuse is 9.49. So this 9 over 9.49 is equal to 9 or 0.948 in decimal form. So essentially what we have is the sine of theta is equal to 9.49 or 0.948, sorry. So whenever you need to take and actually determine what this angle theta is, you have to use the inverse function that you're using. So the inverse trig function here, take it to the other side, it'll be sine inverse of 0.948. Now, it is important that this little inverse function is not the same as taking a variable to the -1, because essentially that is saying 1 divided by that. This is an inverse trig function, totally different from this right here. So all calculator functions should be able to do this. Every single calculator that has a sine, cosine, or tangent function should have the ability to do an inverse function to determine the actual angle. So when you take this sine inverse of 0.948, the angle pops out to be 71.5 degrees, making sure that your functions are in degrees and not radians. So if you get something, if you're following along here and you get something that is not 71.5, you're in radians mode and you have to figure out how to switch your calculator over to degrees mode. So in degrees mode, the sine inverse of 0.948 gives us 71.5 degrees for this angle up here. Alrighty, so let's move on to the cosine of the angle, which should give us the same value here. So cosine of theta is the adjacent over the hypotenuse, which gives us 3 over 9.49, which 3 over 9.49 in decimal form is 0.316. So what we have here is the cosine of theta is equal to 0.316. Once again, take cosine to the opposite side. We're going to use the cosine inverse function of 0.316. And that gives us a value for theta of 71.5 degrees, which is good that it's matching up with the previous one because they should be the same, because it is the same angle. Alrighty, and then we have one more to go, which is our tangent of theta, which equals our opposite over adjacent, which is 9 over 3, which is essentially just 3. So our tangent theta value is 3. So let's see what actual angle gives us this function value of 3. Well, just like before, we're going to take the inverse function, this time tangent inverse of 3. And that gives us 71.5 degrees. So as I said, typically when you want to figure out what this angle is, you're just going to use one of these trig functions, sine, cosine, or tangent, and then take the inverse of that to get the actual angle value. With this particular problem, we were just showing that you could do it either way with the sine, the cosine, or the tangent functions, and their inverse functions. So I hope this video was helpful. And if you want to see more problem solve this Friday, we have other videos on our channel. Please check them out. And we will also be continuously uploading videos like this. If you haven't done so already, please make sure you like this video, leave a positive comment, and subscribe to the channel because it really does help us out. Thank you for watching, and I hope you have a fantastic day.